Here is a very short problem for exponential derivatives. You are in differential calculus. The function to be differentiated is y is equal to sine of x squared e raised to x. We can directly start with differentiation for this function, as it is already simplified into a single term. Having to take the sine of the whole term, we use trigonometric differentiation, where the derivative of sine of u is equal to cosine of u, with the derivative of u with respect to x by chain rule. So following the pattern, y prime is then taken as cosine of u, which is x squared e raised to x. Then connect d upon dx of u, which is x squared times e raised to x. This has two terms placed together, x squared and e raised to x. Thus we use product rule to differentiate it. The derivative of x squared e raised to x then follows the format of taking the first term, x squared, and multiply it with the derivative of the second term, e raised to x. Add to this the second term, e raised to x, multiplied by the derivative of the first, x squared. Now we don't need to focus on anything else but smaller derivatives, which are in green. From the first term, the derivative of e raised to x follows the exponential differentiation pattern of e raised to x with the derivative of u upon dx, which is taken as dx over dx for this term. Dx upon dx is 1, thus eliminating the d. For the succeeding term, take the derivative of x squared, wherein using power rule tells us that the derivative is 2x. Just the same as the first, connect dx over dx, as required by chain rule. And again, dx over dx is 1. Now we can finalize d over dx of u, which turned out as x squared times e raised to x times 1 plus e raised to x multiplied by 2x and then 1 respectively. Simplify d upon dx into x squared e raised to x plus 2x with e raised to x, then connect this back to the trigonometrically differentiated function, and we get the final derivative y prime as equal to cosine of x squared e raised to x multiplied to the binomial x squared e raised to x plus the second term of 2x e raised to x.